Welcome back, pirates. Today we're working on 7.2 systems of linear equations and three variables. Last time we were working on systems of equations with two variables. We're going to add another step. It's not too bad, but I hope it helps. Remember that elimination process? It's going to be done similarly. All right, students will learn how to solve multivariable systems of equations. Okay, this would be a situation where we would have multivariables. And notice that we have a bunch of planes. We have three different planes here. And their intersection, we could have a point of intersection or we could have a line, which I'll show you later. And so we're used to the X and Y axis. But you will also be playing with the third axis, Z. Really, you'll see that later on in life. So maybe in another class, maybe in the calculus or the calculus BC. We'll see. It's in the future. Each point in the coordinate space can be represented by an ordered triple of the form XYZ. A system is similar to the coordinate plane, but has an additional coordinate based on the z-axis. Notice that the axis from three planes that intersect at the origin. So there it would intersect at a point. All right, this is if you were to graph it. We're not going to do that. So we're just looking. That's all. Okay, so it says graph the point in a three-dimensional space. So yes, right here, this one looks like it's at a diagonal, but really what it's doing, it's kind of shooting out, if you will. Okay, it looks weird because obviously it's on a two-dimensional space. So it says from the origin, you would move forward, move 3 units forward along the x-axis and 2 units to the left and 1 unit up. Okay. So again, this is something you'll do later on, not for this lesson. All right, we have consistent system is a set of equations or inequalities that have at least one solution. And then you have inconsistent system where you're not going to have any solution. So I'm going to give you examples of that right now. And I'm going to show it to you using planes. So this one should be pretty simple, where we have all the planes not touching each other, right? Where you would have them parallel. So that would be inconsistent. You'll have possibly a situation like the one in the middle here. Here, you couldn't say that they're the solution because they all should have met at one point or a line. And same thing with this other situation here. If you look at the bottom two situations, notice that all three planes will intersect or touch, right? At this one, it would have one. It would intersect at a point. And then here, you would have infinite many because of the way they're intersecting. It would create that beautiful line that we love to see. Also, make sure that you have your notebook out. All right. Solve using elimination. Make sure you copy this down nice and neat. There will be some work involved with this one. All righto. All right, so we're given three equations, three linear equations, and we need to solve for x, y, and z. So this one actually won't be too bad if my pen works. All right. First thing you want to do or make sure is that you are nice and neat and you start labeling everything. Otherwise, this could become a headache and fast. Okay. The next thing you want to do is determine what variable would be the easiest to eliminate or get rid of. Okay. If I notice here with equation 3, it says z is equal to 1. So guess what? I don't need to do any work here. I could go ahead and put that in there, right there. At this point, I'm able to substitute in afterwards. But right now, I need to determine what I want to get rid of. So I'm going to start playing with equations 1 and 2. I'm going to rewrite equation 1. And then I'm going to write equation 2. And I'm going to determine which variable would be the easiest to get rid of. You probably will need a lot more space than what I currently have. Okay. I notice here that the x's are ready to go. They could be eliminated because they both have a coefficient of 1 with opposite signs, which is exactly what I'm looking for. So that will go away. Excuse me. Then here I would be left with 1y, and then over here I would be left with 7z is equal to 5. At this point, remember that z was equal to 1. I could go ahead and substitute in, and that means I could solve for y. So right now, I'm going to call this equation 4, just to make things easier. So substituting into equation 4, we have y plus 7 times 1 coming from the z is equal to 5. And we're solving for y. Subtracting the 7. Here I'm going to have y equals a negative 2. And finally, at this point, you could, now that you have, now that you solve for 2 variables, you could take these two and substitute it into 1 or 2, equation 1 or equation 2. I'm going to go ahead and substitute it into equation 1 in order to solve for x this time. So for equation 1, we have x minus 2y plus 3z is equal to 9. So this is going to give me a positive 4. Let me bring down the x. Is equal to 9. And so we have x plus 7 is equal to 9. Subtract the 7 from each side, and we get x equals 2. This one was actually pretty. And that is my solution. My solution would be at 2 comma negative 2 comma 1. That would be my triple coordinate there. All done with this one. Let's try another. And we're back for another beautiful example. Again, you want to make sure you label your equations. The neater you are, no. There we go. The neater you are, the better life will be for you. 1, 2, and 3. Okay, just by looking at these 3 equations, you want to start looking to see what variable you could get rid of ASAP, okay? For me, just glancing at it, it looks like the z would be easier. Why? Because the second equation has a coefficient of 1. So I could use that equation 2 twice in order to eliminate the z's. And you'll see what I'm talking about in a bit. Okay, so again, I'm going to get rid of the z first. I'm going to use equation 1 and 2. So I'm going to rewrite equation 1. Again, you want to be nice and neat with this because it's easy to make mistakes. Equation 2. Okay, and we said that we're going to get rid of the z. So here I already have a negative 3. That means down here I want to make it into a positive 3. I'm going to multiply the entire bottom equation by 3. Rewriting the first equation, this was 5x minus 2y minus 3z is equal to a negative 7. Getting your crustiest of dustiest calculator, this would give you 6x minus 9y plus 3z is equal to a negative 48. Okay. Notice now that the z's will go away, and you're going to be left with 11x minus 11y is equal to a negative 55. This is what I'm going to call equation 4 now. Okay. I'm going to repeat the same process. Now I'm going to use equation 3, and I'm going to use equation 2 again in order to eliminate the z, okay? So I'm going to go ahead and rewrite equation 2. Let's go back. There it is. Which is 2x minus 3y plus the z is equal to a negative 16. Equation 3 down below. 3x plus 4y minus 2z is equal to 7. Okay, like we said before, we are going to get rid of the z's. Notice that equation 3 has a negative 2. So that means I need to multiply this top equation by a positive 2. The entire equation. So my equation 2 will look like this. 4x minus 6y plus 2z is equal to a negative 32. Rewriting equation 3 right below. Okay. Now you should notice that the z's will cancel out, and you should be left with 7x minus 2y is equal to a negative 25. This is what I'm going to call equation 5. I'm going to take it to the other slide now. Okay. Now what we're going to do is we're going to join forces. Yeah. We're going to take equation 4 and equation 5 and eliminate the x's or the y's because those two are smaller. And now we're able to determine what the x or the y will be by doing that. And you'll see what I'm talking about in the next slide. So again, equation 4 from the previous slide. I'm going to write it right now. That was 11x minus the 11y is equal to a negative 55. We also had equation 5 from the previous slide as well. That was 7x minus a 2y is equal to a negative 25. Okay. Beautiful. All right, you need to determine what you want to get rid of. Do you want to get rid of the x's or the y's? For me, I think the y's would be a little bit easier, not by much, but it would. So I'm going to eliminate the y's. And I want to make this 11 into a 22. And down here, I'm going to make this into a positive 22. So multiplying the top equation by 2, I should end up with 22x minus 22y is equal to a negative 110. All right. For equation 5, that will get multiplied by a negative 11. And then at this point, you should be able to get rid of the y's. Boom. Bye. What are we left with? Looks like we are left with a negative 55x. And that's going to be equal to 165. Go ahead and divide by a negative 55 to each side. And we should end up with x equals 3. All right, so x equals 3. Let's go ahead and put that in there. Okay, so now I'm going to take my lovely x value, and I could either substitute it into equation 4, or I could substitute it into equation 5. Whichever one, it shouldn't really matter. I'm going to go ahead and substitute into equation 5. So for equation 5, it's up here. So this is going to be 7 times 3 minus 2y is equal to a negative 25. So we have 21 minus 2y is equal to a negative 25. Subtract the 25 from each side. sorry, the 21 from each side. And we should have negative 2y is equal to a negative 46 when I subtract the 21 from each side. Divide by negative 2, and y should be a positive 23. And that goes right in there. Now that I know what x and y are, I'm going to go ahead and substitute those two values into equation 2, because to me, that is the prettiest to my eye. So you want to look back to the previous slide, rewind it, or you should have it in your notes, so look back. All right, equation 2. Equation 2, when I substitute, should look like this. That's going to be the 2 times 3 minus the 3 times 23 plus the z is equal to a negative 16. This would be 6. This would be a negative 69 plus z is equal to a negative 16. So negative 60 plus z equals a negative 16. Add a 60 to each side. What will z be? 44. Yeah. So now we have our solution. 44. So it should be 3 comma 23 comma 44. All right, guys. All done for this one.